Okay, let's get started. Okay, let's get started. Good morning, everyone. So before we start today's lecture, let me advertise a public lecture provided by the Faculty of Business and Economics. This is the annual David Finch lecture. I created an announcement yesterday. You probably have seen it. What's this lecture about? It's about safe assets. It's a hot topic right now in, like if you see any financial or economic news. And who will deliver this lecture is a professor from University of California, Berkeley, Professor Pierre-Olivier Grinchas. He is a very well-known macroeconomist working on international finance. And time, that's next Wednesday, August 9th, in the afternoon, 6:30 p.m. for refreshment. I think lecture starts at 7 p.m. You are all very welcome to join this lecture. Just have a look at what one of the best economists in the world think about the global financial crisis, issues related to that, the safe assets. Okay, what we'll do today is that we'll provide the second building block of the so-called ISLM model. What we did last week, we built the first building block, the IS curve, right? What we did is that we look at equilibrium condition in goods market. There, we find that in the short run, basically equilibrium is determined by aggregate demand. That is, aggregate demand determines production and output. So the equilibrium condition is aggregate demand, that Z thing equals Y. And there, when investment is taken as endogenous, that is when investment depends on income and interest rate, we find for any given level of interest rate, we can find an equilibrium output that give rise to goods market equilibrium, right? Goods market equilibrium is derived from the condition aggregate demand equals output. That's what we learned last week. And this week, we'll look at the second building block, the equilibrium condition in money market or financial market. I use the term money market and financial market interchangeably. And what we will do next after today's lecture is we want to put these two markets together. You notice a big difference between microeconomics, like intermediate micro, and our macroeconomics is that in macroeconomics, we are interested in aggregate economic outcome. So we often put several markets together and look at all these markets together. That's the ultimate goal. We want to do two things today. We first derive the LM curve, and second, we want to provide a very brief introduction of the global financial crisis. And we'll cover quite a lot of materials. It's very likely I can't finish all the slides today. If I leave a few left, don't worry too much. I'll do it tomorrow morning because tomorrow's lecture will be a relatively short one. So don't worry if I don't finish all the slides today in the morning. We'll discuss four specific topics. The first, we look at money demand. What determines money demand? And then we look at equilibrium condition in the money market. And then we look at monetary policy, banks, and reserve, a brief discussion of how central banks conduct monetary policy in modern days. And lastly, it's a discussion of the global financial crisis. We want to highlight two things. The first is the role of leverage, and the second is bank run. There's a lot to cover, and this last bit is related to the public lecture. So if you're interested in what we discussed today towards the end of today's lecture, you might be interested in the public lecture next Wednesday. First, money demand. If you think about when we talk about money in our daily conversation, you say like someone has a lot of money, what does it mean? It probably means that this person is quite rich, right? So in daily conversation, money represents like wealth or income. But in economics, when it comes to economic theory, money has a very particular definition. It's not financial wealth, it's not your income. Rather, money is defined as something that doesn't pay you any interest, but can be used for transactions. So this highlights the role of money. That is, money is considered as a medium of exchange, so it can be used for transactions. In this sense, we call money is very liquid. You can use it to buy things, right? If you show your money, that beautiful piece of paper, to the merchant, you should be able to buy goods. So money can be used for transactions. But money doesn't generate any return. And normally, if you look at the monetary aggregates that RBA or Australian Bureau of Statistics provide us, money, like what kind of assets are considered as money? First, the beautiful piece of paper in your pocket, paper currency, is considered as money because you can use it for transaction that doesn't pay you interest. Second is the direct deposit. What is it? It's basically the money you put in your checking account. So this part of money, although it's not that piece of paper, but you can use your debit card when you want to buy things, right? You can use it directly for transaction. And also, this interest rate on your checking account is really, really low, right? It's nearly zero. So the definition for money in general in economics includes currency and your checking account. And the second asset we consider in our model today is bonds. So what are bonds? Bonds here are referred to as something like the type of assets that are issued by the government. Bonds are issued by the government. It's riskless. It's risk-free in the sense that there will be no risk that the bond will not give you return. Rather, this bond can generate an interest I per period. These bonds pay interest rate I. And the difference between bonds and money in terms of return is this interest payment. The second difference is bonds cannot be used for transactions. So if you have a lot of bonds, you can't use bonds directly in your daily life to buy things, right? Bonds cannot be used for transactions. So now you see some trade-off. Here, we are kind of constructing an economy where there are two assets, money and bonds. Money is very liquid. You can use it for transactions, but it has very low return, nothing, right? Bonds, it is good in terms of return. It gives you interest payment, this I, little I, but you cannot use it for transactions. In some sense, it's not liquid. So that's the trade-off. Then what determines the demand for money then, between money and bonds? If you were to think about how you choose between money and bonds in this simple world, what do you consider? So how much money should I carry? Well, if you want to buy a lot of things, probably you need to carry more money, right? Because only money can be used for transactions. On the other hand, what if bonds pay a lot of interest payment? It would be really nice to get some return, right? In this case, you might want less money. That's why we assume in this world where we have two assets, money and bonds, the demand for money depends on two factors. One, we assume that demand is increasing in the level of transaction. If you want to purchase more stuff, you want to hold more money, and the level of transaction is proportional to income. Does it make sense? I think it does, because in last lecture, we argued that consumption depends on income, right? Just the amount you consume, the transaction demand is proportional to income. So that gives us demand for money is increasing in income. That is, as this Y is higher, income is higher, your demand for money should be higher. That's assumption one. Assumption two is that demand for money is decreasing in interest rate. Does it make sense? It means that when interest rate is higher, this is your opportunity cost of holding money, right? Because if you don't hold money, you can put this to buy bonds, put your money to buy bonds, and in this case, you can earn return. So if the return is high, that means by holding money, you forgo a lot of interest payment. So this interest is the opportunity cost of holding money. The higher the interest, the less you want to hold money, right? And that's why we have the second assumption, demand for money is decreasing in interest rate. And mathematically, what we have here is we use MD to denote money demand. This superscript D represents demand, equals, it's a function of income and interest rate. It equals a particular form here, equals nominal income, price times output, give us nominal income. That's the kind of nominal income. And the second item is this one. This is new today. It's multiplied by this LI. This LI is a function of interest rate. And since we assume that money demand is a decreasing function of interest rate, so this LI is decreasing in I here. It means when I is higher, this L function should be lower. Why we use L here? Well, the reason we use L is this L is the short for liquidity. Somehow we consider like money as being liquid. So the higher the interest rate, like the lower your demand for liquidity. So this L stands for liquidity here. Graphically, we can put all the information we have discussed in this diagram. Normally in economics, at least like from what you have learned so far, when we draw diagram, we often put quantity concept on the horizontal axis, like output, money here, and price type of concept on the vertical axis. Here we have interest rate. So if we draw money demand in this diagram where the horizontal axis is money and vertical axis is interest rate, then money demand can be represented by this downward sloping curve. It tells us that when interest rate is high, money demand is low, but when interest is low, money demand is high, right, downward sloping. And this exactly reflects our assumption too, right? Money demand is decreasing in interest rate. So this assumption too tells us we have a downward sloping money demand curve. As interest rate increase, we have lower money demand. What about assumption one? Assumption one says that when income increase, money demand increase. Well, here, notice that for any given level of interest rate, like here, if income increase, if Y increase, it means that at this certain level of interest rate, money demand will increase, right? So money demand will go this way. And what about another level of interest rate, say here? Suppose it's initially here, the money demand. When the level of income Y increase, money demand will be higher, so you move towards the right. On this money demand diagram, the increase in income will shift the money demand curve out and to the right, right? So now you see the difference between movement along a curve and the shift of a curve. If there is any change in interest rate, that's movement along the money demand curve. On the other hand, if the level of income Y changes, that's a shift of the money demand, right? If income increase, money demand shift to the right. On the other hand, if income decrease, money demand will shift to the left. So we have illustrate both assumptions in this diagram. Now, one way to test our assumption of this LI thing, if someone is still not very sure what is this liquidity thing, the one way to test is a simple test. You can go to the data and remember from our definition of money demand, this liquidity can be written as money demand divided by the level of income, right? Let's use the equilibrium condition in money markets for now. We are going to use it next slide. We'll formally introduce it in next slide. But for now, let's suppose that in equilibrium, money demand always equal money supply. And we can actually construct this right-hand side I wrote there, money divided by the level of income, right? You can go to data, find money supply, and also look at the data, find nominal GDP that give us nominal income. And then you can construct this measure M over PY, and this is given by this gray line here, the gray one. This is from the data. And what you can also observe from the data is interest rate, right? This is given to you if you go to any statistics on interest rate. You can also observe interest rate. Now, this data is given by this blue line. And what do you find? Do you find this M over PY, this liquidity thing, is inversely or is it inversely related to interest rate? Obviously, yes, right? That's actually quite a good illustration. It's clear from this diagram that the liquidity L thing we constructed is inversely related to interest rate. That's why we argue this is kind of one simple way to test our assumption. This Li is a decreasing function of I. And I don't know if you learned it in first year macro, just to give you a bit of more information. This M over Py thing, if you look at the inverse of this Py over M, the economic interpretation of this ratio is the velocity of money. It means that for a given amount of money, if you have a certain amount of income Py, this ratio gives us how many times money has to change hands to support all these transactions. So that's why this ratio Py over M is called the velocity of money. Now, equilibrium in money market is the following. As always, in any market, equilibrium is where supply equals demand. But to make everything more rigorous, let's simplify a little bit, because in the first slide, I said that money includes currency and demand deposit or direct deposits. But for now, let's just look at a very simple scenario where money is only currency. In this case, money supply is simply given by, controlled by the central bank. In Australia, the central bank is the Reserve Bank of Australia. We can consider money supply as being chosen by the central bank, the Reserve Bank. In this case, money market equilibrium condition is given by where money supply equals money demand, and therefore, this money chosen by the central bank, money supply chosen by the central bank, equals demand. This is the money demand equation. Notice that this M, money supply, is chosen by the central bank. Price we take as given in the short run, right? And output we take as given in this case, in money market equilibrium. You notice that for any given M, P, and Y, we can find an equilibrium level of interest rate, right? That is, when money market is in equilibrium, this is where money supply equals money demand, will have an endogenous interest rate, will generate an equilibrium interest rate. This is what money market equilibrium condition tell us. For any given level of income, we will have an equilibrium interest rate. And this will give us the LM curve. We'll formally derive the LM curve in next lecture, but why the name LM curve? This L stands for liquidity, and M stands for money. So basically, LM curve is derived from money market equilibrium condition. This is where demand for liquidity equals supply of money, that type of concept. We have the LM curve. Graphically, this is an equilibrium in money market where we have the downward sloping money demand curve, right, in the space of money and interest rate. And money supply is vertical. Why? Because this is controlled by the central bank. It doesn't depend on the interest rate. It's inelastic here. You see the intersection A gives us equilibrium in money market, where we argue that there is an endogenous interest rate, an equilibrium interest rate that clears money market, right? So this particular interest rate makes money demand equals money supply, right? All the other interest rates cannot do that, right? The equilibrium in money market give us an equilibrium interest rate. Now, you see what we have done so far. With goods market equilibrium condition, what we have is we take interest rate as given, we find an equilibrium level of Y, output or income, right? And with money market equilibrium condition, we take this output or income Y as given, and we find an equilibrium interest rate. And tomorrow, we want to put these two pieces of information together and see how output and interest rate are determined simultaneously in equilibrium. But today, we'll stick with the financial market. Now, let's play with this money market equilibrium condition a bit. What if money supply increase? Well, graphically, if you're good at shifting curves, you know that when money supply increase, that will be a rightward shift of the money supply curve, right? As more money supplied in the economy. And then if we ask you what happened to interest rate, not too hard. Equilibrium move from A to A prime, you see equilibrium interest rate decrease. We're done. Well, the answer is correct, but we want to offer more economic intuition. What's going on here? Well, if money supply increase from this original one to this MS prime, what's going on in the money market? You'll notice at the equilibrium, the original equilibrium interest rate I, when money supply increase, you notice money demand at I is at point A, right? At I, money demand is at point A, but money supply moves to this point B, right? Because central bank increase money supply. Obviously, what we are having is we have an excess supply of money in the money market. Money demand is less than money supply, right? At that original interest rate. This is not an equilibrium outcome. There is too much supply of money. How can we restore equilibrium? Well, supply is controlled by the central bank. We can do nothing about it. But interest rate can adjust to change money demand, right? If there is an excess supply of money, then how should we adjust money demand? We want interest rates to what? To decrease so that money demand could increase to match money supply, right? That's why interest rate decrease, because when money supply increase, there will be an excess supply of money to induce people to hold more money so that money demand increase. To restore money market equilibrium, interest rate should decrease, right? The excess supply of money ask for a decrease in interest rate. Only in this case, we can restore equilibrium in money market. Money demand increase, and we have equilibrium back at point A prime. Now, second experiment. What if the level of income Y increase? Well, we know that the increase in Y will shift out money demand curve, right? We illustrate that early on. So graphically, the increase in income will shift out money demand curve, and money supply is still given as before. So equilibrium here graphically move from point A to point A prime. Interest rate increase. Answer is correct. What about the economic intuition behind this? How does the equilibrium adjust here? Well, if you look at the original equilibrium point at A, at the original interest rate I, when the level of income increase, what's going to happen is that this money demand curve will shift out and to the right. Right? At that old interest rate, if interest rate does not adjust, you know that money demand will be way on the right over there at like point B here, right? So point B gives us money demand. But where is money supply? Money supply is still at point A, right? So what's the situation when money demand first increase in money market? Now we have an excess demand for money, right? Money supply stay there, but money demand shift all the way to the right. So how should money market adjust in this case? When we have excess demand for money, what's going to happen is that interest rate has to adjust in a way to reduce money demand, right? How can we reduce money demand? Interest rate has to increase, right? Because the higher the interest rate, the lower the money demand. So in this case, the disequilibrium is where we have excess demand for money, and that puts upper pressure on interest rate because we want money demand to reduce so that we can restore money market equilibrium. So that's why equilibrium move from point A to point A prime. We know how money market adjusts in this case. There will be an increase in interest rate to clear money market. Well, normally, if there's an increase in the level of income, we see there will be fluctuation in interest rates. In very rare situations, if central bank want to accommodate the change in money demand to stabilize interest rates, that's also possible. Like an example is, say, during Christmas time, everybody wants to go shopping, right? You want to buy a lot of stuff. So there are a lot of transactions. In this case, there will be kind of sudden increase in money demand. And if central bank doesn't want the interest rate to fluctuate because of everybody shopping. In this case, what the central bank can do is to temporarily increase money supply to accommodate the increase in money demand so that interest rate can be stabilized, right? So in this graph, in this diagram, what's going to happen is that central bank can temporarily increase money supply to make sure interest rate doesn't change much, right? We'll talk about how the central bank adjusts money supply next. But before that, let's just use one slide to discuss the issue about bond price. We discussed in the beginning that bonds here are issued by the government, the treasury, promising some payment. Now, there's an interesting formula that we want to introduce. If you're good at finance, you probably know this really well, this kind of computing present value. With bonds, normally, there is some face value. That is, if you hold the bonds till maturity, it's the value that you can get. So suppose the bonds have a face value of $100. That is, if you hold bonds till maturity, you get $100. Let's assume this is one period bond. Now, we're interested in the fair price of this bond. How can we do that? Well, if you're good at computing present value, you know what should happen is, suppose the price of bond is given by this PB. That's the price of bond today. The bond will deliver you $100 tomorrow, and we also know the interest rate from today to tomorrow is this little I. So what should be the price of bond today? That's the question. Then how can we compute that? Well, if you think about the fair price today, say if it's PB, then it should satisfy the price of the bond today. If you pay PB dollar today, what you expect is plus the interest payment. Considering the interest payment, you hold it for one period, hold till tomorrow. That should deliver you $100, right? That's the fair price, right? In this way, there is no profitable opportunity for you to buy or sell bonds. If you buy today at PB, you hold it for one period, get interest payment, you get $100 tomorrow. That's the fair price. And this implies that the following bonds price formula, that is the price of bond, is given by the face value divided by the gross interest rate. And what we want to show here using this one slide is that mechanically there is a negative relationship between bond price and interest rate. So if you hear in the news someone comment on bond price saying that, well, the interest rate has been rising so that we should observe a decrease in bond price, you know that this is definitely true. This is not one leads to another. Rather, this is like two sides of one coin. This is a mechanical relationship, right? A rising interest rate basically implies, on the other hand, the bond price must decrease because this is how the bond should be priced. Now, generally, when the central bank buy bonds, in the market, demand for bond increase, the price of bond increase, accompanied with a decrease in interest rate. And let's discuss more about this. How does the central bank adjust money supply in practice? The central bank does this, change money supply, by what we call the open market operations. Have you heard of this term, open market operations? The central bank really doesn't inject money by helicopter drop into our economy. It's through open market operations. And the expansionary open market operation refers to the situation where central bank buy bonds from the public. And in this case, the central bank purchase bonds with money, and money in the public will increase, right? Central bank buy bonds and give the public money. So money supply increase. The reason we call this an expansionary open market operation is because it refers to the supply of money being increased. So we know that when money supply increase, interest rate will fall. On the other hand, a contractionary open market operation is where the central bank sell bonds to the general public. In this case, the central bank inject more bonds into the economy. And what does the central bank receive from the public? Money, right? That means money in the public will decrease. That's a fall in money supply. That's a contractionary open market operation. In this case, interest rate will rise. We want to show you next how the open market operation affects the central bank's balance sheet. The central bank's balance sheet, as a balance sheet for any other company, it has a liability side and asset side. The assets held by the central bank in a very simple scenario in our economy where we have only money and bonds are the bond holdings. If the central bank holds government bond, that's the asset for the central bank. On the liability side is the money in circulation. So do you wonder why money is the liability for the central bank? Well, I think a good way to think about this is when the central bank creates money and inject money into the public, money becomes the public's asset, right? If you hold money, it's your asset. If I have money, it's my asset. At the same time, the money is central bank's liability, right? If you're good at accounting, you know one thing, if enter asset side in one case, it must be liability in another company's balance sheet. So that kind of concept, I hope that helps you understand why money is liability for the central bank. Money is our assets, it's the general public's asset, but the liability of the central bank. Now, with an expansionary open market operation where the central bank buy bonds using money, what's going on is the central bank will buy more bonds and hold more bonds. An example is that $1 million purchase of bonds will increase the central bank's holding of bonds by $1 million. That increases the central bank's asset, right? At the same time, the central bank needs to use money to buy the bonds. That means the money given to the general public increased by $1 million at the same time. So liability increased by $1 million at the same time. So that's a representation of an expansionary open market operation. You can imagine what will happen if there is a contractionary open market operation. In that case, both liability and assets will decrease on the central bank's balance sheet, right? Now, this open market operation, we'll spend 2 more slides on that. Our model has the notion that the central bank controls money supply and interest rate is determined in equilibrium. That is, we have central bank choosing money supply and the interest rate will adjust endogenously. But if you look at the real world, you look at modern central banks, these central banks like RBA, the Federal Reserve, or Bank of Canada, or European Central Bank, these central banks, they actually don't really control money supply in practice. Why? Because on one hand, money supply is really hard to measure, right? You think about how to get a precise measure of money supply. In Australia, it's not so bad because most of the Australian dollars are held by Australian households. But in US, things are very different. If you look at the data, almost a half of the US dollar are held by foreigners, like they are not literally in the US. So getting a precise estimate of money supply is hard. That's why, in practice, the central bank doesn't really target money supply. Rather, it targets interest rate. Well, can the central bank do that? If you think about the money demand, money supply diagram we just used, for any money supply, there is an equilibrium interest rate, right? If you move money supply, you have another equilibrium interest rate. That means from that diagram, there's this one-to-one kind of relationship between interest rate and money supply. We can think of central bank as choosing money supply. In this case, interest rate will be determined endogenously in equilibrium. On the other hand, it's also feasible for the central bank to target any interest rate. That is, the central bank can choose a particular interest rate. In that case, money supply will adjust endogenously. So think about it. If the central bank, back to the diagram, here, use this one for example. If the central bank says that, okay, I want to target a particular interest rate, say here, 1.5%. How should money supply adjust? Then in this case, the central bank should do the open market operation in a way so that interest rate reach 1.5%, and you know that that will give an endogenous money supply like this one, right? So to summarize, basically between money supply and interest rate, these are two variables that we care about in money market equilibrium. The central bank can choose to only one of these. If the central bank chooses to control money supply, interest rate will be determined in equilibrium endogenously. On the other hand, it's also feasible for the central bank to choose an interest rate, to target a particular interest rate. In that case, money supply will endogenously adjust in equilibrium. So central bank can choose one of the two between interest rate and money supply. In modern central banks, this is what the central bank does when it comes to monetary policy. They often target a particular interest rate. So this is a discussion of the open market operation in practice. In practice, what the central bank has on its balance sheet is on the liability side, we call the central bank has this central bank money or high power money. This includes two things: the currency that we discuss. The second thing is called reserves. These are basically the very liquid assets held by commercial banks. So have you heard the notion that commercial banks need to hold reserve? Why? These are very liquid assets. The commercial bank has a lot of demand for liquid assets, partly from us, right? If we put our money in the commercial banks like Westpac or Commonwealth Bank, we might want to withdraw our deposit, right? The bank doesn't know which day we want to withdraw this money. That's why the commercial bank usually hold assets in the very liquid form, reserves, to meet the withdrawal demand. On the other hand, the commercial bank might also want to pay their obligation to other commercial banks, and that also need liquid assets in the form of reserve. Or in some countries, not in Australia, there is this legal reserve requirement. It forced the central banks to hold liquid assets as a certain fraction of total assets. So all this means that commercial banks, they need to hold very liquid assets in the form of like cash or an account at the central bank. So this reserve and the currency, they constitute the very liquid central bank money. In practice, the central bank adjusts money supply by adjusting the supply of reserve. There is a market for reserve. It's called the interbank market. In Australia, it's called the overnight money market. In this market, commercial banks, they are on the demand side of reserves. They will adjust like how much reserve they need every day. Like after each day's transaction, Westpac or Commonwealth or ANZ, they all decide whether they want more liquid asset or not, depending on that particular day's demand from the bank. And they're on the demand side for reserves. And the supply of reserve can be adjusted by the central bank in this interbank market. And the interest rate determined in that particular interbank market is called the cash rate in Australia in the overnight money market. Determine the equilibrium interest rate is called the cash rate. This cash rate is exactly the interest rate that is chosen by the central bank in Australia. If you are interested in this type of financial news, you might know that the RBA releases its target interest rate every month in a year, except in January. Indeed, yesterday, RBA just released the target interest rate, the target cash rate for August. It keeps the interest rate at 1.5% on hold. So the target interest rate has been 1.5% in Australia for a while. You know that this is exactly the interest rate the central bank target in practice. In US, this interbank market is called the federal funds market. This is probably one of the most important markets that economists will look at around the world. And the interest rate determined in this particular federal funds market is called the federal funds rate. That's kind of the target interest rate in US. And if you look at this plot, I got this from the Federal Reserve Bank's of St. Louis website. It gives you the US federal funds rate from 1955 all the way to now. And there are quite a lot of fluctuations. Interest rate, this federal funds rate could be up and down. But a very special thing occurred only recently. If you were to look at this federal funds rate over time, do you find anything that's interesting? Well, notice the very recent interest rate is close to zero. What does that zero mean? In our model, we have money and bonds to choose from, right? Money doesn't pay any interest, so that means money earns zero return. We say bonds earn an interest rate I. So can this I go below zero? From this one, it seems it doesn't go below zero. Well, in our model, it's certainly the case that there is this zero lower bound on interest rate. Why? Because when interest rate reaches zero, people are just indifferent in terms of return. People are indifferent between money and bonds, right? Both offer no return. And the return cannot go below zero because in that case, nobody would hold bonds, right? The worst is you hold money, that's zero return. So the equilibrium interest rate of bonds, if bonds are valued by individuals in the economy, its interest rate cannot go below zero, right? Why don't you just choose money? Nobody would hold bonds if the interest rate go below zero. So theoretically, that's why you often hear this term, the zero lower bound. Theoretically, the nominal interest rate on bonds, this interest rate cannot go below zero. That's why we call it the zero lower bound. In practice, it's very rare the nominal interest rate can go below zero, but it happened. Actually, recently, as I said, it's very rare. So if you read the news and find that Swiss central bank, its government bond, the Swiss government bond, has a negative nominal interest rate, it's true. It happened, but very rare. Why is that? We can have a whole lecture on that. But in short, in our model, we model only the demand for money and bonds in terms of transaction and return, right? There are other reasons why people want to hold these government bonds, because government bonds, like Swiss government bonds, are considered as very safe assets. So that's why people are willing to hold it, even if it offers negative return. They are used for other purposes, like collateral or other purpose in the financial market. We don't model in our lecture. But if you're interested in safe assets, that public lecture would be a good place to find out more. So what we want to do next is this zero lower bound is certainly very special because it actually creates a problem, what we call the liquidity trap. We'll come back to liquidity trap probably next week. But for now, let's talk a little bit about why we have this zero lower bound. What's going on in US in recent decades? This is the global financial crisis. Global financial crisis started in US, and it's triggered by the US housing market collapse. What's going on in US is, this is the Case-Shiller index constructed by two economists in US. And it takes January 2000 as 100. It's an index, so it has a normalization. January 2000 as 100. Notice the highest of the housing index goes to 226 in 2006, and then the index became stable and then collapsed, right? A big decrease. In the US, in the early 2000s, the housing price keep increasing, and that's kind of good news for the US households, because even if they are not rich enough, in a sense, rich enough to buy a house, they want to buy. What's the worst? If the housing price keep increase, they get mortgage, they buy a house. The worst is they just sell the house and the housing price will increase. They can still pay off their mortgage, right? That's why the banks also perceive that there's not too much risk if they lend to these risky borrowers. Australian banks have very strict lending standard, but at that time, US commercial banks perceived that lending is relatively safe even to risky borrowers. Even if the housing price, even if they sell their house, what's the worst? They can get the money and they can still repay the mortgage. All this is fine if the housing price keep increasing. The problem occurs when the housing price starts to turn down. So at that time, a lot of the risky borrowers, like the households in US that are not financial wealth enough, they have mortgage, they buy houses. When the housing price decrease, what's going on is that even if they sell their house, the price is not enough, the value of the house is not enough to cover the mortgage. So in this case, what can they do? They default. And that is called a subprime mortgage crisis. In US, around 2006, out of all mortgage loan, 20% mortgage is classified as subprime mortgage. These are the mortgage loans that were extended to the risky households, the risky borrowers. And when the housing price decreases, these risky borrowers, they find out they cannot repay the mortgage loan anymore. Even if they sell, they will not be able to repay, they default. And that triggers a decrease for commercial banks' assets, right? Commercial banks extend loans to these households, and these households default, so the asset for commercial banks decrease. And that triggers, in total, a $3 billion loss of financial wealth in US economy. Well, is it big, 300 billion? It sounds big, but if you look at US GDP, it's not that big. US GDP is 15 trillion per year around that time. So if you think about this loss from the submortgage loan crisis, it's only about 2% of US GDP. But global financial crisis is big in the sense that the economy afterwards is in a recession, and it's called the Great Recession. The depression in 1920s, 1930s is called the Great Depression. And this one, after the global financial crisis, is called the Great Recession. And clearly, it has very big impact on not only US economy, but also the global economy. The question is, why? What's going on? What triggered the response? Like a 300 billion loss in the financial market trigger like global impact. We want to discuss two things. One is the leverage. That's kind of amplification mechanism. You see how a small loss for bank assets will trigger bigger loss for the economy. And the second is bank run. On leverage, leverage is defined as the ratio, if you have a bank balance sheet, the ratio of total assets to equity. Now, a very simple example, suppose a commercial bank has investment that worth 500K and liabilities 400K as deposits. These are the money we put in the bank, deposits. And the left 100 is equity. This is what shareholders of the bank can claim, 100K. In this case, leverage ratio is 500 over 100. Now, consider two scenarios. If the value of investment increased by 10%, if the value of investment, if it's in good time, investment has good return, it generates 10% return, the investment will worth 550K, right? After paying out deposits, what's left for shareholders of the bank? That's 150K, right? You see that a 10% increase in the value of investment for the bank will mean a 50% increase for shareholders, right? 50% increase in return for shareholders. But what if the economy is not so well, like the return from investment decreased by 10%? In this case, value of investment becomes 450K, and after paying out deposits, 400K, shareholders are left with 50K. You see, a 10% decrease in the value of investment or the value of assets for the commercial bank means a 50% decrease of return for shareholders, right? So this means the leverage itself amplifies the return for shareholders of the commercial bank. And now I have all the calculation here. Imagine if the value of investment decreased by 20% in my example above, then there will be nothing left for shareholders, and the bank is on the verge, on the edge of insolvency, bankruptcy, right? So this is exactly what we want to discuss next. We'll show you a typical commercial bank's balance sheet and how that translates into financial crisis and economic crisis. We'll discuss that tomorrow morning.
still understand this view. So in this page, you said when the economy is in recession. So firstly, so what's the difference between recession and depression?
Oh, I think depression is like a more severe recession. So recession and boom are the normal terms that we use to describe when an economy is in a bad time is called recession, and a good time is called a boom. And technically, like in US, there are some agencies that provide a precise definition what can be classified as a recession, like the output has to decrease for a certain percent for a certain period. That's a recession. It's not like if today the output decreases, it's a recession. It has to satisfy certain criteria to be a recession. And the Great Depression is where the recession lasts for a very long period, and the decrease in output is even more dramatic.
Okay, got it. So in here you said when the house price just keep going down. So once if the banks sell their houses, they can't.
If the households sell their houses.
Still can't make up the amount.
Right. So, like, if say your house was $100 when you buy it, and say you borrow $80 from the bank, you pay for the rest $20.
Yes.
And if housing price increase, this is not a problem. But what if your house decreased to say $50?
$50.
Right. Even if you sell it on the market, you only get $50. How can you repay your $80 loan? Right.
Okay.
That's the problem.
So why you say that the bank is gonna to bankrupt?
Because these loans are given to the households by the banks. So these loans sit on the asset side for the bank.
Yes.
Right? So the bank basically is part of the bank's investment.
Yeah.
The bank thinks that you pay interest rate and give return so that the bank can pay for their depositors. But you default, you can't pay for the loan. So the return the bank expected would not be able to realize. Right?
Okay. So they have to be they can't pay the interest rate to the depositors.
Right. That's exactly what will illustrate more through the balance sheet of the commercial bank. So if you come to the lecture tomorrow, you'll see more discussion.
Yeah, sure. Thanks, man.
Friday lecture started.